Well, welcome back to the perfect square videos on calculus conundrums finding the derivative. And in this video we're going to talk about how to find derivative of the natural log function. And so I'm going to give you two formulas. The first formula is just finding the derivative involving natural log of x with respect to x, and that equals 1 over x. And so what I'm going to do, let me go ahead and just do an example here. So if you want to find the derivative of x squared minus natural log of x, you just figure out what's the derivative of x squared. We all know that's 2x. And then from this formula, we know the derivative of natural log of x is just 1 over x. So we would have 2x minus 1 over x. Now, but what happens if you're taking the natural log of a function where u is a function of x? Well, it works similarly, but in this case you would have 1 over u times the derivative of u. So you would apply the chain rule. So if I were to give you this function here, which is y equals the natural log of that polynomial, that trinomial there, then we would simply say the derivative is 1 over the trinomial and then times the derivative of the trinomial. So we would multiply by the derivative of the trinomial. And the derivative of this trinomial would be 6x minus 5. So basically what we'd have is we'd have 6x minus 5 for the numerator, and we'd have 3x squared minus 5x plus 1 as the denominator. So that would be our final answer, 6x minus 5 over 3x squared minus 5x plus 1. Now, let's apply some other rules to these. Let's say we wanted to find the derivative of the natural log of x raised to the 4th power. Well, on that we could simply use the general power rule. So we would have, using the power rule, we would have 4 times the natural log of x to the 3rd power. But remember, on the general power rule, you also have to multiply by the derivative of the inside. So the inside is natural log of x. So we'd have to multiply by the derivative here of natural log of x. And we know the derivative of natural log of x is just 1 over x. So finally we would get 4 times the natural log of x quantity cubed, and then times 1 over x, which you could just write like this: 4 times the natural log of x quantity cubed, all divided by x. And so that's your derivative there. What about a product rule? Let's do a product rule of x squared times the natural log of x. Well, the product rule, we can take the first function, which is x squared, multiply it by the derivative of the second function, and we know the derivative of natural log of x is just 1 over x. And then we can take the second function, which is natural log of x, and multiply it by the derivative of this first function here, x squared, which we know is 2x. So then we can simplify this a little bit. We know that x squared divided by x is just x, and so we can write our final answer as just x plus 2 times x times the natural log of x. And that's our derivative for that one. Could also throw in a quotient rule. So here we have natural log of x over e to the 2x. So that would be, using the quotient rule, I would take the denominator, e to the 2x, and then multiply it by the derivative of the numerator, which would be 1 over x. The derivative of natural log of x is 1 over x. And then minus the numerator, which is natural log of x, times the derivative of the denominator. And the derivative of e to the 2x is actually e to the 2x times 2. And then I would have that over e to the 2x squared. Now when you square e to the 2x, you just double the exponent. So we would get e to the 4x. So that's pretty much all we'd have there. Now what I did to get the next step, I'll go ahead and show you what I did, because I didn't actually show you on here. But what I did is I saw this 1 over x. So I said, well, why don't I multiply everything in the numerator by x and everything in the denominator by x, and then that way when I multiply this, all of this by x, it'll just cancel. So when I multiply x by all of that, it'll just cancel the 1 over x, and I'll just get e to the 2x for there. And then when I multiplied it by this term, I would get an extra x in there. So if you look, you'll see there's an extra x right there. So I have 2x times the natural log of x times e to the 2x. And then also, if I multiply the top by x, I had to multiply the bottom by x. So I multiply the bottom by x, and I get this right here, x times e to the 4x. And then I was able to do some factoring. So notice that I have an e to the 2x here, and I also have an e to the 2x in the second term. So if I factor e to the 2x out of here, I just get 1. And then if I factor e to the 2x out of here, I get 2x times the natural log of x. And then the last step is I took e to the 2x, and when you have e to the 2x over e to the 4x, that leaves you with e to the 2x in the denominator. So in other words, you can cancel this into this and just get e to the 2x. Okay, so my denominator is just going to be x e to the 2x, and my numerator is just going to be this quotient, this 1 minus 2x times the natural log of x. And there is your derivative simplified. Now, the next one, if you're a business calculus student, you can probably skip it, but I went ahead and wanted to do one with a trig function. So this is the natural log of cosine of x. And so when you take the derivative, remember, of natural log of u, you do 1 over u, so that'd be 1 over cosine of x, times the derivative of cosine of x. And the derivative of cosine of x is minus sine x. So we would have minus sine x in the numerator and cosine x in the denominator. And it turns out that minus sine x over cosine x is actually minus tangent x. Okay? I actually did 2 here. Here's another one. Here I have the secant of the natural log of x. And so here you have to do this as a trig rule. So we have to go back to the rule for trig functions. So how do you find the derivative of secant u, where u is this natural log? Well, the derivative for secant of u would be secant of u times tangent of u. So I'd have secant natural log of x times tangent natural log of x. And then you multiply by the derivative of u, which would be the derivative of natural log of x. Now, the derivative of natural log of x is just 1 over x. So basically what I would get is this product, secant natural log of x, tangent natural log of x, times 1 over x, which could be written as secant natural log of x, tangent natural log of x, all divided by x. And that's pretty much it on the natural log function. Now, on the next video, I'm going to talk about when you're finding derivatives of log functions that have bases other than e. Remember, the natural log function is a function with base e. So natural log of u is really log of u base e. And so, but what happens if we have to find the derivative for log of u of another base? And so we'll see that on the next video.